right, 4.6. Now we're going to be graphing the other trig functions. We're going to start with secant and cosecant. I'm going to go over this part and then we'll do tangent and cotangent. So to graph secant and cosecant, these two, we must be able to graph sine and cosine. So remember, when we're dealing with sine, the reciprocal is cosecant. But if you can graph sine, then you will see that here at the center, wherever it crosses the center, it's going to be our vertical asymptotes. Because remember, when you have 0 and you take the reciprocal, it will be 1 over 0, which means it's a vertical, it will be a vertical line. So these are going to be your asymptotes. Okay, our period is still going to be 2 pi, okay, but we do not have all real numbers. It's going to be undefined at specific locations. Now this table basically is the same thing as before. 0, 1 over 0 is undefined. 1, flip it, you still get 1, and so forth. So we're going to be using that table. We're going to be using the points as well. Same thing for the other one. If we have secant, the reciprocal is cosine. So we must be able to graph cosine and then use the points where it's at 0 or at the center, and then that will become our asymptotes on the secant graph. Okay, let's go ahead and do a few of these. Here's the basic information for your secant and your cosecant function. Okay, so let's go ahead and graph. First thing I want to do here is I'm going to use another equation to help me graph this. So I'm going to say we are going to use y is equal to -2. Take the reciprocal of whatever this trig function is. In this case, if it starts with C, it's going to be with an S. Sine of 3x. We're going to graph this first, and then we'll be able to graph the reciprocal function of that next. Okay, first thing again, A is going to be a 2. There is reflection on here, so keep that in mind. Let's go ahead and write the period. Period is equal to 2 pi over B. B is going to be 3, so I have 2 pi over 3. Okay, that's our period. Remember, after that, we're going to find our sections. Our sections are going to be 2 pi over 3. And we're going to divide it into 4 parts. So once I simplify this, the 2 goes into 2 one time and 2 goes into 4 2 times. That makes it pi over 6. Okay, that's our sections. There is no horizontal shift, so we're going to start with 0. And then we're going to add pi over 6. That will get us our second point. I'm going to go ahead and highlight those in purple like I've been doing on the other ones. Okay, plus pi over 6. That's 2 pi over 6. I'm not going to simplify quite yet. Plus pi over 6. That's 3 pi over 6. That's 4. And then plus pi over 6, that's 4 pi over 6. Okay, if I look at the difference between this and this, it's going to be 4 pi over 6. If I simplify that, that period will be 2/3 pi. So here's our sections, 1, 2, 3, 4. Here's our point, 1, 2, 3, 4, 5. So we have them all matched. Now let's go back to the sine function. Where does that tell us it's going to start at? Sine, hopefully you remember, starts in the center. And which direction are we going? This negative says we're going down. Okay, there's no other horizontal or vertical shifts. So let's go ahead and graph those points. I'm going to go ahead and start at the 2. So I'm going to go ahead and graph my line here, my top. And then the bottom will be -2, which is right here. Okay, and the center is still going to be along the x-axis. I'm going to go ahead and draw that as well. Okay, now this part is important. When I'm actually graphing this, I am going to graph the sine function using a dashed line, because remember, this is what we're using to help us, but that's what we're actually graphing is this function here. So this is going to be in a dashed line while I'm graphing. Start at 0, start at the center, so that's going to be my first point, and then I'm going to go down. Okay, here's pi over 6, that's going to go down. The next one will go in the center, then I'm going to go up, and then I'm going to go back to the center, and that is 2/3 pi. I know it's hard to see. Now that I have it dashed, I'm going to go ahead and continue. This will be up, center, down, center. So it will continue to look like that. Okay. Now, anything that you have on the center, anywhere where it's crossing the center line, is where our asymptotes are going to be. Okay, so I'm getting another marker. I'm going to go ahead and use orange, and I'm going to mark anywhere where I'm crossing the center at these points. That's where my asymptotes are going to be. So I'm going to go ahead and draw my asymptotes. Okay, there are my asymptotes. Asymptotes are also a dashed line. Now for my actual function, I'm going to go ahead and draw it. I'm going to use red color because this is the actual graph I want to draw. Anytime you have the peaks here, the minimums and the maximums, that is where you're going to connect your actual graph. And then I'm going to go ahead and draw the lines just like this. So the function that I'm drawing right now is the cosecant. Okay, cosecant. That is essentially the only part that you really need to know. This part in red. Okay, and there you go. So you see what I mean? If you don't know how to graph your sine and your cosine functions, you won't be able to do your secant and your cosecant functions. Okay, if we go to part B, notice that these are exactly the same, except now hopefully you know that this is a vertical shift. So all the information we did is exactly the same, except you're going up 1. So what I'm going to do with this one is I'm not going to do the math again, but I am going to show you what the graph looks like. I'm going to start my center by going up 1. So here's going to be my up 1. Okay, that's my center. Then I'm going to go ahead and graph the top and bottom 2 from the center. So 1, 2, here's the top. 1, 2, here's the bottom. Okay, all your other points are the same. Everything else is going to look practically identical. I'm going to go ahead and do this here, and then here, 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 and here, and then we're going to go backwards. So this will be there, 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 and there. And now I'm going to draw my dashed line. Okay, then I'm going to use my orange highlighter. I'm going to find a different one. Hopefully this one's better. And I'm going to mark anywhere it's crossing the center will be my vertical asymptotes, just like that. And finally, I'm going to use my red marker to draw the function. It approaches the asymptotes, but it will never cross. It does touch that point with the sine or the cosine function. Okay, so it's just going to be like that. So the only difference between these two is that this has a vertical shift up and this does not have a vertical shift. Okay, that's it for this section. Let's go ahead and talk about what I think is probably the harder section of the graphing is your tangent and your cotangent. For this part, we're going to go ahead and go through the unit circle again. All right, when we're evaluating tangent, and we're going to go ahead and start with tangent since that's what we have here. When we're evaluating tangent, we need to remember where is tangent undefined. Remember, tangent is y over x. So if I'm starting out at tangent 0, tangent 0 is equivalent to 0 over 1. This means that tangent 0 is equal to 0. So if I look on the graph here, again, the x-axis is referring to the radians, which is 0. Here you have the term 0, 0. Let's go ahead and go on to the next part. If I go up, I see that tangent pi over 2 is going to be 1 over 0. Here is where tangent is undefined. So if I go forward, pi over 2, there's an undefined line. So tangent is going to be undefined when theta is pi over 2. If I go down, it would be negative pi over 2, which is this point right here. So now that you can see that I have an entire rotation, okay, another rotation occurs here. So if you look at the period for tangent and for cotangent, the period is not the entire unit circle because it is cut here and here from the vertical asymptotes, meaning that you have 2 full rotations into pi, which means that there's 1 full rotation in a pi. Okay, so important things to remember for this is the tangent restrictions are going to be negative pi over 2, this is for the domain, and positive pi over 2. That's our starting domain. Let's go ahead and look at our range. When we're looking at our range could be, y could be any real number. So that's another difference between the other 4 trig functions and these trig functions for tangent and cotangent. Alright, let's go ahead and look at cotangent now. Now, cotangent is x over y. So when I'm looking at cotangent of 0, I'm looking at 1 over 0. Well, here, cotangent is going to be undefined, which means cotangent will also be undefined at pi. Okay? If I go to cotangent of pi over 2, that's going to be equal to 0 over 1, which is the same thing as 0. So let's look at that function. Okay? So undefined at 0, undefined at pi. Here's my vertical asymptote at 0. Here's my vertical asymptote at pi. And right in between is pi over 2, which is right here, and that's equal to 0. Okay? So if you use your unit circle, you can see that cotangent also has a period of pi, but it's in quadrants 1 and 2, where tangent has a period of pi, and that includes quadrants 1 and 4. Okay? So these are important for us to know. Domain is the restrictions between 0 and pi. Okay, it doesn't include 0 and pi, and your range is going to be all real numbers again. Okay, so those are the information that we have here. Okay, so and that kind of goes through this entire thing of what I just explained. And then over here on the back side, you have the same kind of information where it talks about our domain restrictions, our range is all real numbers, and where it's bounded at. Okay, period is going to be pi. And then the other thing is, remember these 2 functions are going to be odd. Okay, so these 2 trig functions are odd. We're going to use the same type of format as we did before. We could do it the previous way that I was doing it with the other ones, but the thing that I find the most difficult for students is knowing where our vertical asymptotes are. Okay, so let's go ahead and start by graphing. Okay, we're going to start by graphing this problem. Let me get a little closer for you. There you go. And here it says graph y equals cotangent for x. Okay, first thing, A. A is going to be the number before the trig function. In this case, we don't have a number, so it's automatically assumed to be 1. Okay, B. B is equal to 4. Our period this time is not 2 pi over b, but pi over b. Pi because their period for tangent and cotangent is just 1 pi. Okay, next thing we're going to do is go ahead and list where our asymptotes are. Okay, so for cotangent, if you don't remember, you can always use your graph. Cotangent is going to be undefined at 0, and at pi. So what I'm going to do here is I'm going to say 0 and pi. These are my restrictions. So I'm going to use this 4x right in the middle of that. I'm going to solve for x by dividing by both sides by 4. So that's going to get me 0 x pi over 4. These two are going to be our new asymptotes now, because remember the b changes the period from pi to pi over 4. So I'm going to go ahead and get my highlighters. I'm going to use, let's use purple. Here's my 0, positive pi over 4. So I'm going to have an asymptote here, and I'm going to have one there. Okay. If I were to go backwards, I'm going to use the same distance. So here, if I went forward 2, I'm going to go backwards 2. Now, when I'm looking at this problem, remember that these are your asymptotes. All I'm going to do is physically divide this between the asymptotes in half. That's automatically going to be our center. So our center is going to be there, and our center will be there. Okay, now how do I use the 1? Okay, so just like before, when we were using these, we were saying, okay, 1, 2, 3, 4 sections. Now when we're using our half a circle, we're going to be using, this is section 1, this is section 2, this is section 3, and this is section 4. For tangent and cotangent, let me show you. I'm going to start here by doing the asymptotes. I did it in purple, so I'm going to do cotangent. There's our asymptotes for cotangent. I'm going to go ahead and put that here. Cotangent. Those are the asymptotes. Okay. Now, my 4 divisions are going to be, this is number 1. This is going to be our first number. Here's going to be our next number, and then here will be our next number. So we have 1 section, 2, 3, and 4, and our 5 numbers, 1, 2, 3, 4, 5, using half a circle. Okay. Now, I've already done the asymptotes, which are purple here. Our center is where cotangent is 0. Remember, 0 over 1 is the same thing as 0, so that's the center. Now I'm going to divide between the center at 0 and the asymptote, which is our purple line. So if I cut this distance in half, it will be somewhere around there. If I cut this distance in half, the center will be about there. So look at this. I have the purple, purple. First line, center, center, second line, and then the asymptote again on this side, which is right here. So here's my 1 part, 2 parts, 3 parts, and 4 parts. Asymptotes is what's approaching. Here's the center. Now, cotangent. Is cotangent positive or negative in quadrant 1? Well, I hope you said it was positive, because all trig functions are positive in quadrant 1. So if you look at the first asymptote, the first asymptote is here. The numbers are positive between the asymptote and the center of the period. So all of our numbers are going to be positive here. Once it hits 0, which is at this point, then cotangent becomes negative, which means it's going in this direction. Okay. All right. So where do we put that A? Well, in the center of from the asymptote to the center, in the center of that, so the first section, A is 1. So that is actually where I'm marking my point. Okay. So I have 1 point here, the center, and then -1 right there. So when I'm drawing my graph, it's going to approach the asymptote, come through those 2 points and the center, and then finish off on the other side. Same thing occurs here. You're going to approach the asymptote, come through the point, the center, and the other point, and come out through the other side. this is how we would graph our cotangents. Okay, we're going to do a few more, and we're going to include shifting and so forth. So let's go ahead and do that for number 3. Okay, for this problem here, I'm going to go ahead and list the basic information. A is going to be equal to 4. Okay, tangent, first let's identify where are the asymptotes for tangent. If you don't remember, go back to your unit circle. We did the ones for cotangent here. The ones for tangent are going to be at negative pi over 2 to positive pi over 2. So that's where I'm going to start here. I'm going to say negative pi over 2, and then I'm going to use my symbol, and anything that you see in parentheses goes in the center. 2x plus pi over 3, whatever's in the center goes here, and that's going to end at pi over 2. So always use the asymptotes on the unit circle for that trig function. Next thing I'm going to do is I'm going to manipulate, and I'm going to solve for x. In order to do that, you first have to either add or subtract the horizontal shift. So I'm going to subtract pi over 3 to both sides. Okay, that will leave here just with a 2x because these will cancel out. Use your calculator to do the rest. So I'm going to just go ahead and start with negative 1 divided by 2 minus 1 divided by 3. Remember, you don't have to include the pi. Second, PRB, and you get negative 5 pi over 6. On this side, you're going to be doing 1/2, and I'll just go back up. It'll be positive 1/2 minus the 1/3, and then second PRB, and you're going to get 1/6. So here will be pi over 6. We're not done yet. We still have a 2 here. We want to eliminate that, so we're going to have to divide everything by 2. This is not going to be subtraction here. Okay, so all I'm going to do is multiply. It will be negative 5 pi over 12 x pi over 12. If I look at the distance between these two, you're going to have 6 pi over 12, because the difference between these two is 6 pi over 12, which is the same thing as pi over 2. So let's look at this. B here is 2, which means the period has to be pi over B, which is pi over 2. Here the period matches what your period would be here. Okay, so first thing I'm going to do is go ahead and draw my asymptotes according to my new asymptote. So negative 5 pi over 12 is actually way over here. Positive pi over 12 is right here. That's where my asymptotes are going to be. Next thing I'm going to do is just count. So I have 1, 2, 3, 4, 5, 6. I'm going to go 6 in this direction. 1, 2, 3, 4, 5, 6. It so happens to be here. Next thing I'm going to do is go halfway between. Okay, we don't have a vertical shift, so it's going to stay, the center is going to stay on the x-axis. And now we're going to cut these asymptotes into 4 parts. Okay, I'm going to do half of this, which is going to be right here. Half of between here is going to be right 1, 2, 3, right here. Okay, so 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. Then once I get the center, I'm going to take half between the asymptotes in the center, which would be 1.5. So here's 1.5. Okay, so here would be my other main part, 1.5. 1.5 right here. So if you look, you still have 5 numbers, 1, 2, 3, 4, 5, and you still have 4 sections, 1, 2, 3, 4. Now let's go back over here. A is going to be 4. Okay, so let's look at tangent real quick. Again, before we mark our A, let's go back to tangent. Okay, if tangent is the asymptotes are undefined along the y-axis, looking at the very first axis, which will in this case be the one negative, if I'm looking at tangent in this quadrant, tangent is going to be negative. Once it hits 0, then it will be a positive value. So when I'm looking at tangent here, tangent into the 0 is going to be negative. So here, if this is 4, I'm actually going to draw my point in the negative section at -4, okay? Then over here, it will be positive, so you would have +4, and our trig function would look like this, approaching the asymptotes, crossing through the major points, okay? I'm going to do the same thing over here. There's my main point, and there's my main point. This is going to be a -1, this will be a +1, and the asymptotes are being approached by the trig function but won't touch. Okay, and there you go. You have them done now. All right, we'll go ahead and do another one where we do have a reflection, and we also, if you notice here, we also have a vertical shift. So that's actually where I'm going to start first on this one. I'm going to do my vertical shift. I'll use my green marker for that, and I'm going to go up 2, which is right here. This is going to be my new center in this case. Okay, so now I have my new center. Let's go ahead and continue with this part. This part, tangent, remember, identify your asymptotes. Also, I want to note here that A is equal to 1, okay, and there is reflection. So we're going to keep an eye on that. But before that, we're going to go ahead and list the asymptotes. Asymptotes for tangent are -π/2 to +π/2. In the middle here will be whatever you have attached to the x. We do not include the 2 because this is not a horizontal shift. This is a vertical shift. The difference between these two is this is in a parenthesis, so it needs to be included. This is not in a parenthesis. That means it's a vertical shift. You do not include the 2. You only include the 3π/4. 3π/4 x. Okay, we're going to isolate the x, and we're going to multiply everything by 4/3π. That makes all of the 3π cancels, and the 4 also cancel, isolating the x. What you do to one side, you have to do to the other. So I'm going to go ahead and put this in parentheses and do 4/3π, and then I'm going to do 4/3π. Okay, let's go ahead and cancel everything. X is now alone in the middle. Over here, you can see that your pi's will cancel. You have a negative. 2 can go into 4 2 times. So I have a -2/3. Okay, -2/3. Over here, your pi's will cancel. 2 can go into 4 2 times, so you have a +2/3. Okay, so let's go ahead and check our period. Period is going to be pi divided by b. B is the entire number here, so I'm going to do pi, and I'm going to flip this. This will be 4/3π. Okay, pi's cancel, and you're left with 4/3. Well, what's the distance between here? Well, if this is 0 in the middle, you're going to have 2/3 going to the left, and you're going to have 2/3 going to the right. At that, you get 4/3. So your period matches the distance or the difference between these two asymptotes. Okay, let's go ahead and draw our asymptotes at -2/3 and +2/3. There you go. So I have the negative and +2/3. The center in this case is going to be right in the middle at 0, which is right there. So that's always going to be your 0 point between the two asymptotes. Now, tangent, let's look at this. This is the negative side. This is the negative side because this is negative going down or going back. This is originally a negative value, but a negative times a negative makes this be a positive value. So I'm going to go up 1 right in the center. And over here, here's the center right here. I'm going to go down 1. So here your function is reflected. There is a reflection there. And that's what that function is going to look like. Okay? So when there's a negative, instead of starting down here and going in this direction, we're actually flipping it and going in the opposite direction. Okay, I do recommend that when you're going through these videos, do the first section and then go to the worksheet and try a couple of those before moving on. It does build up on each other and it will help you a lot more. All right, let me know if you have any questions.